proceed.
Thank you.
Thank you, ma'am.
Is my screen visible?
Yes, ma'am, it is visible, but you can make it full screen.
Yeah.
Yeah,
Is
ma'am.
it okay now?
Yeah, ma'am. Okay.
Yeah. Okay. So thank you very much again, Nanda sir, for giving me this opportunity.
Thank you, Sipanna ma'am. Your video, can you please make it on?
Yeah. Where is this? Let me show. See. Yeah. Now it is.
Okay, welcome to the next second lecture.
Yeah. Thank you, sir. Yeah, thank you. Yeah. So, in the last class, I was discussing about the application of multi-objective optimization for clustering, for solving the clustering problem. So, in today's talk, I will be discussing about the applications of multi-objective optimization in solving some problems of in natural language processing. Okay. So, in recent years, we have applied multi-objective optimization for solving some tasks of NLP. So, I will be discussing about them briefly. So just to recap that, you know that because this FDP is on multi-objective optimization only. So in multi-objective optimization, we are simultaneously optimizing multiple objective functions. Like suppose we are having two objectives, cost and comfort, while we are purchasing a car. And you know, cost and comfort are conflicting objective functions. So either we have to minimize cost and we have to maximize comfort, and it is not possible to simultaneously optimize them. So if you can, if you are minimizing cost, then comfort will be also minimized. Comfort will be also minimized.
मैंने फटाफट
And
कंप्लीट किया
if
तो
you
अभी
are,
आधा घंटा और खींचती थी.
sir, can you mute yourself, sir? And if you are maximizing comfort, then the cost will also go high. So the cost and comfort are conflicting objective functions, and it is not possible to simultaneously optimize both the objective functions. So these kind of problems are called multi-objective optimization problems. And there is another kind of problem called the single objective optimization problem, where we are simply optimizing a single objective function. Like we are optimizing only cost. And you have seen that in this case situation, we are simply, getting a set of solutions on the Pareto optimal set. And these are called the non-dominated set of solutions. And these non-dominated set of solutions are called Pareto optimal solutions. Like solution 1, solution 2, and solution 3 are the non-dominated solutions. And solution 1 is better with respect to safety, but solution 2 is better with respect to cost. And solution 3 is better with respect to cost also. So now depending on our requirement, like if we prefer safety more, then we will select solution 1. But if we prefer cost, like if you want to minimize the cost, then we will prefer solution 3. So our task is to provide the users a set of non-dominated solutions, and then the user can select a single solution from this non-dominated set. So I have already discussed about the formal definition of multi-objective optimization. Like there will be a set of vector decision variables x and some constants, and we have to simultaneously optimize some objective functions. So objective functions could be cost, comfort. These are the objective functions, and the constants could be that mileage will be greater than equal to 20 miles per hour, and the seat for 6 adults. So these are the constants. And there is no concept of global optima, so it is not possible to get a single solution which will simultaneously optimize all the objective functions, but rather we will be getting a set of non-dominated solutions, and which is called the Pareto optimal set. And then we have to select a solution from the Pareto optimal set. So here in this example, I have shown you how what is the non-dominated set of solutions. Like if there are two objective functions f1 and f2, both are maximization type, then you know solution 1, 2, 3, and 4 are non-dominated to each other. And for example, you can compare solution 2 and solution 3. So solution 2 is better with respect to f2, but solution 3 is better with respect to f1. So we cannot say solution 2 dominates solution 3 or solution 3 dominates solution 2. So solution 2 and 3 are non-dominated to each other. and you know the both of them are equally good. But if you compare solution 5 and solution 2, solution 5 is dominated by solution 2 because in both the objective functions, solution 5 has lower objective functional values than solution 2. So now coming to the summarization problem. So summarization is a very traditional task of natural language processing. So summarization means the task of automatically creating a compressed version of the text document. So suppose you have a long text, or you have a multiple tweets, or you have multiple web pages, or you have multiple documents. Now can we get a concise, relevant, non-redundant, non-redundant and representative of the main idea of the text. So basically, you know that suppose we have a long text, and we want to generate a concise, relevant, non-redundant and representative of the main idea of the text. So this is called the summarization task. And you know that a text that is produced from one or more text and that conveys the important information in the original text, and that is no longer than half of the original text and usually significantly less than that. So basically you have huge amount of text data and nobody is having time to go through such a long text data. So what we want is that a concise summary, so that we can read the summary and we can understand the entire document. So this is the summarization task. And you know that there are many motivation for solving the summarization task because internet is flooded with information. There is so much of information available in the internet. Like there are in the internet, in the social media, there are many tweets. Like suppose there is a disaster situation, disaster happened. During the disaster situation, people lost the physical connectivity, but people stay connected with each other using the social media platform. So they used to tweet about the current situation. So we can download all the tweets and then we can generate a summary of the tweets. And also, you know that newspapers, like suppose there is a event happen and several news reporters are reporting the event. So there are several news reports around the same event, but maybe nobody is having time to go through all the news. So we can collect all the news and can generate a summary out of those news. So users are facing difficulty and they do not have time to go through all the news and all the tweets. So can we generate a summary after considering all those news documents or after considering all the tweets? So automatic text summarization system is needed that can compress information into shorter length, that must follow coverage of information, non-redundancy, information significance, and cohesion in the text. So basically, you know that you have a large number of text and you do not have time to go through the long text. So can we generate a summary of the same just to save some time of the users? So there are several goals of the summarization systems. So summarization systems can eventually save the time of the users because now the summary, you need to only read the summary and you will get the understanding of the entire event. You do not have to go through the entire document. And it will also compress the large information. So you no need to go through the large information in present in the long document. So this will help us in compressing the large information. Active reading, this will also help in active reading. Easy to implement. Decision making, because as I mentioned, microbox summarization helps the rescue team in decision making. So you know people are expressing their current situation in the tweets. So maybe we can gather all the tweets and then we can do a summarization of the tweets. And now this summary can be given to the rescue team and the rescue team can plan for the rescue operation. So for the summary, for the decision making, summarization is very, very useful. And also highlight the central theme. So what is the central theme of a particular document? That is also important. That can be easily identified by the summarization tools. So summarization is mostly of two types, extractive and the abstractive. So extractive means that suppose you have originally 100 sentences. So now you select 10 most important sentences from the original document. So if your original document is containing 100 sentences, you select which 10 sentences contain most important, most information. And those 10 sentences will be part of the summary. So this is called the extractive summarization. We are extracting the important sentences and forming the summary. Abstractive summarization means we are, suppose originally there are 100 sentences. We are reading those 100 sentences and then rewriting the summary in our own words. So this is the abstractive summarization, where we have to first understand the original text. We need to understand the meaning of the original text, and then we have to write the summary in our original way, in our original sentences. So here we cannot copy the sentences from the original document. We have to write down the summary in our original by natural language generation process. So here you can see that colored sentences, the first is the example of extractive summarization, where the colored sentences are simply copied from the paragraph. So here we are selecting the sentences from the original paragraph. And the second is the abstractive summarization, where first we are understanding what is written in the document, and then we are writing the same paragraph in our own words. So there are different applications of summarization problem. One is called that query focus summarization. Suppose we are summarizing with a particular query like Taj Mahal, and we are getting multiple documents. So now can we summarize all the documents which are related to a particular query? If we are summarizing a single document, then this is called the single document summarization. If you are summarizing multiple documents, then that is called the multi-document summarization. Suppose there is a figure given, and given a figure, we are generating the summary of the figure. Like, in biomedical articles, figures, it is very difficult to understand the figures. The figure descriptions are often given in the text. And you know that those are very elaborative description. So can we generate a summary of those descriptions? And so figure is the input, and we have to generate a summary of the descriptions of the figure. Then if suppose we are summarizing the web pages, then this is called the web-based summarization. Sometimes a customer care company is receiving several emails, and we need to summarize the emails. This is called the email-based summarization. And now there is also personalized summarization. Suppose user is interested in a particular topic. Like suppose there is a game, like there is a sports match has happened. In the sports match, there are many players and there are many teams. So in a news article, reporter has somehow mentioned about all the players and all the teams, but maybe user is interested in a particular player only. So this is called the personalized summarization. So we need to only focus on a particular player, and we need to generate a summary for that particular player only. So we have to extract all the sentences which are related to the particular player, and then we have to, after extracting those relevant sentences, we have to generate a summary out of those sentences. Now there is also sentiment-based summarization. People after purchasing product, people are writing reviews of the products in the online platform. So you can collect those reviews, and then we can generate a summary of the reviews. So this is called the opinion summarization or the sentiment-based summarization. Then nowadays there are many events has happened, and then people are often tweeting about the events, and especially during the disaster situation, after the disaster has happened, that people are writing about the disasters in the Twitter. So we can collect those tweets, and then we can generate a summary of those tweets, and the summary can be given to the rescue team, and the rescue team can plan for the rescue operation. So this is called the microblog summarization. So these are the different types of summarization techniques. And for developing a summarization technique, either we can apply the supervised technique, Like if we have label data, like if we know the gold standard summary, and then we can apply the supervised summary, supervised technique, or we can also apply the unsupervised or the clustering based technique for generating the summarization tools and techniques. So in summarization, why often summarization problems are formulated as a multi-objective optimization problem? Because in a summarization field, there are many conflicting objective functions. For example, in summarization, we often have to increase the, we have to select those sentences which are diverse in nature. Like if suppose in the extractive summarization, we are selecting carefully a subset of sentences. So if the sentences are conveying the same information, then that is not useful. We have to select carefully those sentences which are diverse in nature. Then the second is that length of the sentence should also be long. So mostly if the length is, if the sentence is lengthy, then that means it must contain more information. Then in particular document, the initial sentences contain more information than the middle sentences or the end sentences. Mostly in the first few sentences, news reporter used to convey the most of the information related to the event. The coverage, we need to cover the entire event in the summary. Cohesion, the somehow the sentences in the summary should be related to each other. And also we need to increase the readability aspect of the summary. And also the sentence similarity with the title should be also increased. So these are the various factors of the objective functions which should be simultaneously optimized by using a multi-objective optimization framework. So as I mentioned that there are different types of summarization problems. One is called the generic summarization, where, suppose we have a set of documents and we are simply summarizing the set of documents. But the query focused means with the documents are somehow connected and the documents are retrieved based on a query. Like suppose there is a query called Apple and the documents are all related to the topic Apple. Then if you have original ground truth summary, then we can apply supervised technique. And if we don't have the ground truth summary, then we have to apply unsupervised technique. If all the documents are written in a single language, then this is called the monolingual summarization. And if suppose the documents are written in multiple languages, then this is called the multilingual summarization. And suppose in a document only some portion is written in one language and the other portions, like there is a code mixing, like the documents are written in multiple, a document is simply written in multiple languages. This is called the cross-lingual. Then if we are summarizing the web pages, then this is called the web-based summarization. If we are summarizing the emails, so suppose a customer care company has received several emails and we are summarizing the emails, then this is called the email-based summarization. And as I mentioned that if suppose a person is interested in a particular aspect only, and we are simply identifying the sentences which are related to the aspect, and then we are summarizing only those sentences, then this is called a personalized summarization. And if we are summarizing the opinions of the customers related to a particular product, then this is called the sentiment-based summarization. So we have done a thorough literature survey and we identified that most of the works are mostly based on single objective optimization. So they were simply optimizing a single objective function as an optimization function for solving the clustering problem. So there are many meta-heuristic optimization based summarization techniques, like people have used genetic algorithm, differential evolution for solving the summarization problems, and they have mostly used only one objective function for solving the clustering problem. So these approaches suffer from the following drawback. So these approaches are not able to identify the appropriate number of clusters. So because the summarization problem can be now solved into two phases. Like now I will discuss about a possible way of summarizing the documents, and I will be talking about the I will be talking about the basically that extractive summarization, where we will extract the important sentences from the document, and I will discuss about the unsupervised way of summarizing the documents, and it is having two phases. In the first phase, we will cluster the sentences into some semantic clusters. Like if suppose some sentences are conveying the similar information, so they will form a cluster. So we'll first cluster the sentences into some semantic groups, okay? And then from each group, we'll select some sentence, and then we'll form a from the summary. So the summary will consist of the some important sentences selected from each cluster. So this way, in a two-phase manner, we will form the clusters. So these approaches suffer from the following drawback. The existing approaches suffer from the following drawback. So when we are clustering the sentences, how many clusters are optimal, that number is very difficult to determine. So the existing approaches are unable to determine the appropriate number of clusters. And the second is that, that none of the existing approaches are clustering the sentences in the semantic space. But obviously, we should do in a semantic space, because if two sentences are semantically similar, then they should form a cluster. And also the existing methods are having very low convergence rate, and they are also not able to produce good quality summary. So basically, we formulated, when we are clustering the sentences into some meaningful clusters, we optimized multiple objective functions. So in the last class, I discussed about how we can formulate the clustering problem as a multi-objective optimization problem. So here also, we are formulating the sentence clustering problem as a multi-objective optimization problem, where we are solving simultaneously multiple objective functions. So this is the solution, that we are developing a two-phase approach. In the first phase, we are clustering the sentences, and here we are grouping the sentences in the semantic space, and we are simultaneously optimizing multiple objective functions, and we are also determining the number of clusters automatically, and several objective functions are simultaneously optimized. And afterwards, when the clusters are formed, we are scoring, giving some scores to each sentences. So, and then after scoring the sentences, we are carefully selecting some sentences from each cluster to form the final summary. So the sentences which are having good score are selected, and then those sentences form the final summary. And this summary is having a score. We are comparing this generated summary with respect to the goal summary. Goal summary means the actual summary written by the human annotator. And when we are comparing them sentence by sentence, we are able to receive a very good root score. So this is the two-stage approach. First, we are performing sentence clustering. Then we are ranking the clusters. Then we are extracting some good sentences from each cluster, and that way we are forming the summary. So, and when we are clustering the sentences, we are simultaneously optimizing multiple objective functions. So the problem of sentence clustering is formulated as a multi-objective optimization problem, where sentence clusters are identified in an automatic way. And and as I mentioned, that this approach is very generic. Any multi-objective optimization technique can be used for clustering the sentences. Like we can utilize genetic algorithm or differential evolution and colony optimization, particle optimization for clustering the sentences. So what is in order to compute the semantic similarity between two sentences, we have used the word over distance. So the word over distance is the amount of distance that the embedded words of one text needs to travel to reach the embedded words of another text. So like suppose there is a sentence, Obama speaks to the media in Illinois, and there is a sentence, the president greets the press in Chicago. So we have to check what is the semantic similarity between two sentences. So Obama will first we have to do a mapping. So OMA will be mapped to president, speaks will be mapped to greet, media will be mapped to press, and the Illinois will be mapped to Chicago. First, we will be doing the mapping, and then we have to find out the semantic similarity between the two words. So what is the semantic similarity between OMA and the president? Semantic similarity between the speak and the greet, semantic similarity between the Illinois and the Chicago, semantic similarity between the press and the press and the media. So this way we have to find out semantic cosine similarity or the semantic similarity, and the summing up all these distances will be the word mover distance between these two sentences. So if two sentences are semantically similar, then the word mover distance will be equal to 0. So this way we are computing the semantic similarity between two sentences. So you know that these are the various meta-heuristic algorithms that are existing in the literature. We have genetic algorithm, differential evolution, particle sum optimization, Gray-Wolf optimization, water cycle algorithms, and we are utilizing mostly, our approach is very, very generic. Any algorithm can be used as an optimization technique, but in our approach, we have used this differential evolution as the underlying optimization technique. So this is the basic of evolutionary algorithm. In the evolutionary algorithm, there must be an individual. A solution is called an individual. It is following the biological phenomena. This evolutionary algorithm is inspired by the biological phenomena. A solution is called the individual. Representation of a solution is called the chromosome. Components of the solution are called the genes. And the set of solutions are called the population. And the survival of the fittest is inspired by the Darwin's theory. And we are applying two operators, crossover and the mutation. And the iterative procedure is called the generations. So basically there are many individuals, and all the individuals are called the population. And we are applying the crossover and the mutation on the solutions to pattern the solutions, to change the solutions. And then we are evaluating the objective functions of the solutions to finally calculate which solutions are the best. And it is following the biological phenomena. It is basically following the Darwin's survival of the fittest. This is the overall flowchart of the evolutionary algorithm. Firstly, we will be randomly initializing the population, and then we will evaluate the fitness value of each individual, and we will check whether we have reached the maximum number of generations or not. And we will apply the mutation and the crossover operation to generate the new solutions. We will evaluate the fitness values of the new solutions, and we will update the population based on the fitness values. And again, there will be a check. So either we will discard the old solutions, we will compare the new solutions with respect to the old solutions. And if we found that the new solutions are better than the old solutions, then the old solutions will be replaced. New solutions will be retained in the population. And this way, there will be iteration. There is a loop, and the loop will continue until we get G max, generation maximum number of generations. And finally, we will be getting a set of paratoptimal solutions, and those will be reported. So differential evolution is an optimization algorithm and is an instance of an evolutionary algorithm, and it involves maintaining a population of candidate solutions. And we are applying different operators, genetic operators, crossover, mutation, and selection over a number of iterations. Like we are randomly picking two solutions from the population. We are also choosing a target vector, then calculating the weighted difference vector of the two solutions, adding a third randomly chosen vector. Then we are applying the crossover with the target vector to get a trial vector. Then comparing smaller cost value survives into the next generation. This way, we are keep on applying these operators, like selecting two random solutions, building the weighted difference vector, adding a third randomly chosen vector, applying the crossover with the target vector to get a trial vector. Smaller cost values survives to the next generation, and then we are storing those solutions in the population. So these steps are repeated multiple times until we get the maximum number of generations. So this is our problem definition. So first of all, we have to cluster the sentences, and here we'll be applying the multi-objective optimization. So we will be optimizing multiple cluster validity indices. So in the last class, I mentioned about 3 indices: I index, SIM index, and the connectivity based index. So here also we have to simultaneously optimize multiple cluster validity indices to cluster the set of sentences into some meaningful clusters. So that is our objective function. So basically we have formulated the ESDS problem as a sentence clustering problem using multi-objective optimization. And we are optimizing two objective functions, PBM index and Zybani index. And we are clustering, you know, so basically, that we are clustering the set of sentences, and that so we are clustering the set of sentences, and we are optimizing two validity indices, PBM index and the Zybani index. And yeah, so this is the idea. So basically, there are we applied various meta heuristic algorithms like differential evolution, water cycle algorithm, and the Gray-Wolf optimization. And the 3 different versions of the algorithm are developed. One is the multi-objective water cycle algorithm, multi-objective differential evolution, and the multi-objective Gray-Wolf optimization. And so the same as I mentioned, that the approach is very generic, and any meta heuristic optimization can be applied to solve this particular problem. So what are the key points? So basically we have used the word mover distance to calculate the similarity or dissimilarity between two sentences. And then a multi-objective clustering technique is developed to cluster the sentences present in a document. And we optimize two objective functions. PBM index is very, very similar to I index. And the Zybani index is another Euclidean distance-based cluster validity index. So in the yesterday's class, I discussed about the SIM index, I index, and the connectivity based index. But here we are simultaneously optimizing PBM index and the Zybani index. And this algorithm is capable of determining the number of sentence clusters from a given document, and makes use of several sentence coding features to select some informative sentences from each cluster. So this is the differential evolution. So basically this is our proposed approach. So we have a single document, we are doing some pre-processing, then we are initializing the population, we are checking whether we have reached the Gmax or not. Then there is a self-organizing map training, because we are clustering using self-organizing map. We are projecting in a lower dimensional space, as well as we are clustering in a lower dimensional space. Then we are applying some differential evolution genetic operators like crossover, mutation, selection, etc. And we are generating the new population P dash. Then we are merging P and P dash, and we are applying selection. We are selecting the best set of mod P solutions, and we are updating the self-organizing map training data. And finally, we are obtaining the set of paratoptimal solutions, and we are generating the summary and selecting the best set of summaries. So this is the chromosome. So our chromosome is consisting of some sentence cluster centers. So because we are clustering the sentences, so the cluster centers are also some sentences. So you know that each cluster center is represented by a set of words. So that way, the chromosome is consisting of some cluster sentences, and each sentence is basically is a embedding. So these are the sentence numbers, and each sentence is basically represented as an embedding. And number of how many clusters will be there in a chromosome, now that number is varying between 1 to n. So we are randomly generating a number between 1 to n, and those many clusters are encoded in a particular chromosome. Okay, so that way we are also determining the number of clusters automatically by the search capability of the meta heuristic optimization technique. And we are optimizing and each solution is having two objective functions. One is called the BBM index, another is called the Ziveni index. These are the two cluster validity indices, and both of them are the functions of compactness and the separation. Then we are computing the matching pool, and also we are applying the crossover and the mutation. So matching pool is this. Matching pool is constructed after considering the neighborhood solutions of the current solution retrieved using self-organizing map. So suppose H is your current solution. We are seeing what is the neighborhood of the current solution. So if H is your current solution, we are searching for the neighborhood of the current solution. So this neighborhood is our matching pool. So now for the crossover and the mutation, the solutions in the neighborhood will take part. So H is our current solution. So solutions in the neighborhood will take part in matching pool construction, and the solutions in the matching pool will take part in mutation and the crossover operation. Only neighboring solutions can mate to generate the new solutions. So this is the crossover operation. So we have randomly, these are the two solutions generated randomly from the selected randomly from the population xi1 and xi2, and xi current is the current solution. So we have randomly selected two solutions from the matching pool, and xi current is the current solution, and then we are generating the yi dash as follows. CR is the crossover probability. If the rand number is less than crossover probability, then yi dash is less than equal to xi current plus ape is another constant into xi1 minus xi2. Otherwise, y equal to xi current. Rand is a random probability lying between 0 to 1, and CR is a crossover probability. If suppose after generating this number, this is crossing the, each variable is having a limit. If it is either less than the lower limit or greater than the upper limit, then we are changing the value. So if y dash is less than the lower limit, then we are making it up to lower limit. If this is greater than the upper limit, then we are converting into the upper limit. Now the mutation operations. So there are three types of mutation operations. So either we are changing the clusters, sentence cluster centers, or we are either increasing the number of clusters by 1, or we are decreasing the number of cluster centers by 1. So after preparing the solutions generated by the crossover operation, we have applied the concept of polynomial mutation, which generates highly diverse solution. So what we are doing is that we are either increasing the number of cluster centers. So initially, suppose there are 3 cluster centers. Now we can either increase the number of cluster centers to 4, or suppose there are 3 cluster centers. Now we are decreasing the number of cluster centers to 2. So, and also, or you can also apply polynomial mutation. So we are simply changing few of the cluster centers. So these are the 3 possible ways of mutation. Now environmental selection. So after the crossover and the mutation operations, we will be getting a new set of solutions. So we'll merge the new set of solutions with the old set of solutions, and we will get 2p number of solutions. So p dash is our new population, p is our old population. So p and p dash will be merged together, and now we have to apply the non-denominator sorting and the crowding distance-based operator, very similar to NSGA2. So we'll basically partition the these 2p solutions into different ranks. So for example, if the objective functions are maximization type, then A and B are the best 2 solutions, which are the parent surface 1. They are the rank 1 solutions. These 2 solutions are non-dominated to each other, and they are also rank 1 solutions. C and D are dominated by A and B, but they are non-dominated to each other. So they are the rank 2 solutions. E and F are the O solutions. So they are the rank 3 solutions, and they are dominated by CD and also AB, and they are called the rank 3 solutions. So this way we are basically making ranking of all the solutions. Okay. And also, and then we will form the new population. So we'll start with AB. We'll copy AB first, and then we will go to CD. So this way we have to stop where we will not be able to accommodate a particular rank, all the solutions in a particular rank. So suppose you are not able to accommodate C and D both in the population P, because you do not have any sufficient space. In that case, we have to apply the crowding distance. So solutions which are in a less crowded region will be given more priority, and those solutions will be selected for the next population. So this way we are applying the environmental selection operation. Now the summary generation. So at the end of this, we will be getting some sentence clusters. So we'll get some sentence clusters, and now this is the time to assign some ranking to the clusters. So at the end of the optimization algorithm, set of solutions are obtained, and now row score of all the solutions are calculated with respect to goal summary. So a solution having the best row score considered as the best solution. So what we are doing is that we are calculating the to generate the summary for the ith solution, following steps are followed. So first we are calculating the document center. Okay, so the document center is the particular cluster, particular sentence whose average distance with respect to all the sentences is the minimum. Okay, so the document center is the particular sentence whose average distance with respect to all the other sentences is the minimum. So we are computing the word mover distance only, because the distance is calculated in the semantic space. So that's the sentence whose average distance with respect to all the other sentences is the minimum is basically selected as the document center. And now we are calculating the the distance from the center to all the cluster centers. Okay, so zk is the so we are computing the distance from the center to all the cluster centers, and then based on zk we are sorting the clusters. So zk is kind of a ranking. So basically finally clusters are ranked in descending order based on the zk score. So if zk is small, then the ranking is high, and if the zk is large, then the ranking is so if zk is small, then it is in the ranking order. It will come first, and if zk is high, then in the ranking order it will come last. So basically, zk is the distance between the cluster center and the distance and the document center, and clusters are ranked in descending order based on the zk scores. Now there are multiple sentences in a particular cluster. Those sentences are also ranked. So for ranking the clusters in a particular, for ranking the sentences in a particular cluster, we have used these objective functions. The length of the sentence, we want to increase the length of the sentence, because if the sentence is having higher length, that means it is conveying more information. Position of the sentence in the document. So initial sentences are conveying more information. Similarity with the title, if the sentence is more similar with the title, then it is more important. Anti-redundancy. So if if two sentences should be dissimilar to each other, so anti-redundancy should be minimized. So these four criteria, these first three criteria has to be maximized, and the last criteria has to be minimized. So based on this, we are optimizing. There is a sentence score: alpha into f1 plus beta into f2 plus gamma into f3 plus delta into f4. So we are rearranging arranging the sentences in descending order present in a cluster according to the sentence scores. So now we are visiting the clusters in a rank-wise manner, and then from each cluster we are selecting the sentence which has the highest sentence score. Okay, and that will be the part of the summary. So once we have visited all the clusters, we will again start from the very beginning, and this way we have to scan through all the clusters in a rank-wise manner, and from each cluster we will be selecting the sentence with the highest sentence score, and that will be the part of the summary. So this process will continue until we are reaching the summaries. Each summary is having a limitation or length limitation. So until and unless we reach that limitation, we will keep on doing this. So now to generate the summary, clusters are considered rank-wise. Given a cluster, top-ranked sentences are extracted sequentially until summary length reaches to some threshold in terms of number of words. So we executed this algorithm on two datasets, DOC 2001 and DOC 2002, because both these data sets are having gold standard summary. Like there are some manually written summaries available. So for example, DUC 2001 is having 30 topics. DUC 2002 is having 59 topics. There in DUC 2001 is having 309 documents. In DUC 2002 is having 567 documents. And length of the summary in words is 100 in each case. Basically is a metric here. So you basically compare, it is a string matching. So your algorithm is generating a summary and you have the gold standard summary. So now you need to check how many words, consecutive words are matching. So this is a string matching. So n-gram is basically how many consecutive words are matching. So in the gold standard summary and in your generated summary. So n represents the length of the n-gram. Count match n-gram is the maximum number of overlapping n-grams between the reference summary and the system summary. So this rules is basically a measure of similarity. And these are the results. So the first three, this is the differential evolution based approach, Grey-Wolf optimization based approach, and the water cycle optimization based approach. And differential DE based approach is giving us the highest rule score value of 21%. And also, and for DUC 2002 also, DE based approach is giving us the rules to value of 34%. So these are some of the results. You can see predicted summary, mostly it is very much matching with the gold standard summary. And here also you can see there are some hallucinations, but mostly there is a match. And these are the parameters of the proposed approach. And these are the parallel solutions, which means that we are getting multiple solutions on the parallel surface. Like it's not like that we are getting only a single solution, but we are getting multiple solutions. So that means there are multiple ways of optimizing the clusters, optimizing the objective functions. So there are multiple possible ways of generating the summaries. So we're getting multiple possible summaries by simultaneously optimizing the Zybani index and the PBM index. So you know that so in our next work we have what we have. So here it was a two-step approach. First of all, we are clustering the sentences, and in the second step we have ranked the clusters, and then from each cluster we have selected some sentences which will be part of the summary. In our second work, we have what we have done is that we have developed an automatic single document extractive summarization technique using multi-objective binary differential evolution. Like we are encoding the sentences in the chromosome only, and we are directly selecting which sentences will be part of the summary. Okay, it is not a two-stage approach, but now we are directly selecting which sentences will be part of the summary. So, here we are optimizing all these objective functions: sentence similarity with the title, sentence length, readability, coverage, cohesion, sentence position. And many of the objective functions are conflicting in nature. Like if you want to increase the diversity, then the readability will be compromised. If you want to increase the coverage, then obviously the cohesion will be compromised. So this way, many of the objective functions are conflicting in nature. So, so that was the idea. So basically, we have optimized this sentence position. So we want to select the sentences which are having at the initial position of the document. Similarly with the title, we want to maximize. Coverage also we want to maximize. Length of the sentence also we want to maximize. Cohesion is basically it measures the relatedness of the sentences that make up the summary, or it recognizes whether the summary sentences are discussing about the same information or not. And readability means it is checking whether the sentences are highly related. It improves the readability of the document or not. So this is the proposed approach. So now here in the chromosome, we are encoding the sentences and we are directly selecting which sentences will be part of the summary. So this is the flow chart. So there is a pre-processing and population initialization. This is the binary chromosome. We are randomly initializing the chromosomes. And then there is a some training data we are updating, and the other steps remain the same. We are applying the proper operators. So operators will also change because now it is a binary chromosome. And then the selection operation is very similar to the non-numerical sorting operation of the NSGA2. And finally, we will select the best P solutions. And this loop will continue till generation maximum number of times. So there are two approaches. Either we are simply optimizing all the objectives simultaneously, or we can also assign a weightage to the objectives. Like if we know that some objectives are having higher weights, then we can put a higher weightage to that objective function. So all the objective functions are multiplied with their respective weights, and then we can simultaneously optimize. And in objective approach 2, all the objective functions values are simultaneously optimized. So, and then we have either we are first projecting the data in a lower dimensional space, and then we are finding out the matching pool by using the self-organizing map, and then crossover and the mutation operations are applied on the matching pool selected by the SOM, or maybe we are simply applying the differential evolution crossover and the mutation operation without applying the self-organizing map. And various distance measures are also used. Like there are different ways of computing the computing the semantic similarity between two sentences. Either we can use word mover distance, or the normalized Google distance, or the cosine distance. So these are the results. So you can see there are many solutions on the parallel front. It is possible to get multiple solutions on the parallel surface. And these are the 3D plots. So we are simultaneously optimizing 3 objective functions simultaneously. And these are the results on 2 data sets, DUC 2001 and DUC 2002. Yeah, I think I can stop and I can take some questions. So yeah, so basically you can please see these papers. These are the corresponding papers. So ACM, the papers are published in ACM Transactions on Multimedia Computing and IEEE Intelligent Systems, and the IEEE Transactions on Computational Social Systems. So you can visit my webpage, and also you can read these papers, and you can see, like, for more details you can visit these web papers, and you can find out the more details about the data sets and etc. But these data sets are available online, and you can download the data sets from there, and the ground truths are also available online. Yeah, but I think I can take some questions. Sir, any question?
Ma'am, questions are in the chat box.
Yeah.
Participants, all you are requested that your queries, just write those queries in the chat box, please. Some
I'm not able to hear you, ma'am.
Ma'am, some of the research scholars are sitting here, and while delivering your lecture, they were asking that, ma'am, any book you can refer to them because they are new to this field. They have started their work. So, can you suggest?
So for the NLP, I think there are, you can refer to this NPTEL lecture by Professor Pushpa Bhattacharya. So there is a very good NPTEL lecture series by Professor Pushpa Bhattacharya. So you can refer to that. Nowadays, generative AI is becoming very, very important because almost like initially people were working on optimization tools and techniques for solving the summarization problems. But nowadays, mostly people are using because Chat GPT and generative AI are very good in solving the summarization problem. So I think you can also do a course on generative AI, because if you are working on the summarization problem, then these generative AI tools are also very good. So there are many LLM based courses nowadays in NPTEL. So you can also refer to those courses. And there is a book on NLP, deep learning using NLP.
Okay, ma'am.
I can write here
Yes, ma'am.
NLP using deep learning.
বই পড়বে।
Yeah, this one. Manning, by Christopher Manning.
Natural language processing.
By Christopher Manning. There is a book. I see. Yeah, this one. Foundations of Statistical Machine Learning.
Ma'am, your video is not sharing, so we could not see.
Yeah, here I am typing. I have typed.
Okay, okay, ma'am. Got it,
Yeah.
ma'am.
Yeah. By Christopher Manning and so they are the pioneers of NLP. So maybe you can refer to this book. This book is really very good. So if you can read this book, you will get all the understanding of the NLP clear.
Okay, ma'am.
No question from the audience side? Yeah, someone has already typed deep learning for a natural language processing. Yeah. Yeah, this is also a very good book. Deep learning for natural language processing. What you have written is that is also a very good book by this author. Yeah.
Siparna ma'am,
Yeah. Suggest for beginner course on LLM. So beginner course on LLM. So I think you can see some in IIT Delhi. There is a there are some courses available. There are some YouTube videos are available. Okay. On generative AI. You can see those videos. Those are freely available in the YouTube. So those are very fundamentals. Many industry people have also taught those courses on generative AI. So you can see those videos, and then also you can visit this web page, Manish Gupta. So Manish Gupta is a principal scientist of Microsoft. So he is regularly uploading many videos on in YouTube. He has his own blog. He's uploading many videos on generative AI. So you can also visit his blog or his YouTube channel for generative AI. Sorry, Nanda sir, you are saying something.
Yeah, so I was taking your suggestion little bit for improvement little bit while using the chat GPT and all these large scale language models. When the scholars are using and researchers are using, what will be your advice for them for writing the research manuscript, taking these large scale language help and writing their manuscript, and from a researcher point of view as well as from an evaluator point of view, what will be your suggestion on it?
Yeah, you can use it, but like obviously limited use. Like sometimes, so if you are stuck, you are not able to express yourself correctly, then only use it. Okay. Otherwise, you know, people nowadays, this plagiarism softwares are also trying to integrate this AI generated text. So you know, almost all the plagiarism softwares are working very hard. How they can detect the AI generated text. So otherwise there will be a big plagiarism issue also. So better to write in your own words. And if you are really stuck, you are not able to write, then maybe you can take some suggestions and then rewrite in your own way. But ChatGPT, no doubt, is a very good platform, but do not misuse it. That is the suggestion. That maybe a few paragraphs or maybe few lines in the introduction. You know, because obviously ChatGPT is very sophisticated. Like it will generate a very sophisticated English, which may not, he is not required in a technical writing. No, when we are writing scientific writing, we do not need very sophisticated writing like ChatGPT, because the way ChatGPT writes is very sophisticated English. But in scientific writing, we may not need those sophisticated writing. We need very straightforward writing. So maybe you are good in that. So, but if you are stuck, you are not able to convey your idea correctly, then maybe in writing 1 or 2 sentences, you may take the ChatGPT's help. But not for writing the whole paper.
True.
Because in many cases, then you have to also add ChatGPT as an author.
Yes, true. So thank you, ma'am.
Thank you, Nanda sir, for remembering me.
No,
Thanks a
no,
lot.
it is always a pleasure when you deliver the expertise talk. From last several years, you have been helping us in a very good way in this advanced optimization technique program, and we hope for fruitful collaboration in future also.
Looking forward. Yeah.
Sure.
Thank you, sir. Thank you.
Thank you.
Okay. Bye bye, sir. Bye.